Hi, I'm Justin Hansen, and I'll be going over the Robotics I midterm. So for the midterm, we ran two different tests, or two different programs. One that made a robot play tic-tac-toe with a human, either having the robot go first or the human go first. The robot needed to have certain edge cases that it accounted for, whether the human would put two of their shape or if they would put the wrong shape. The the robot would need to kind of display an error case. In my case, it would draw an E. And for this first video that I'm going to show, it is the robot playing with a human. Um, and so you'll see the human play second, the robot will go first. It first finds the home, finds a safe position, and starts drawing the board. In my code, I have it save the four corners and the tops of each box for kind of easier detecting of where to put each shape, either an X or an O. The robot's going to go first. I have it put an O in the bottom slot, bottom left slot, the first time for every run when the robot goes, just because that's where I normally go. I put an X in the top spot, and then now there's a wait time before the robot takes a snapshot and makes its move, and I'll cut to when it makes its move. So what happens here is the robot will go down to its viewing position, take 10 snapshots, find a grid in those snapshots. If it can't find a grid, it skips that snapshot, and it takes the one that it has the most confidence in to move forward with. It looks for the middle position first when placing its own shape, and then it looks for how it can block me when it's putting another shape. Obviously, I had nothing special, so it didn't try to block me, but now it does. The wait time's a lot shorter now because while the robot is going, the countdown for when it takes a snapshot is still moving. So right now, it will take a snapshot now, but since I haven't done anything, it doesn't detect that anything happened, so it waits until I put something down. I don't have to fix the X here because I trained my vision model on a lot of variation with X's, like squiggly ones and rotated ones, but I just like to make it look a little neater. And so now it sees that it's free to win, and I let the robot win because it looks nice when it draws its winning, rather than me making a draw. And now it'll draw a straight line from the first winning box to the last winning box. And then finally it waits before drawing who won, which in this case was the robot. And so I have it draw an R. In the next video, I'll show how robot versus robot tic-tac-toe works. It ends in a draw because both robots are looking to block each other, and they're not smart enough to get out of that. So in this one, I have the other robot draw the field, or my friend's robot draw the field, draw the grid, and then I turn mine on, and it starts waiting. And because he drew the grid, he also goes first. He puts a circle in the center, and then I'll cut to, or I won't cut, but I'll show when he checks again, there's nothing new. He moves back to his position, and then in 3 seconds, mine will go and put its first X down. So mine looks at the board, sees something is down already, and picks the first open spot to put an X in. And next, his robot's going to look, and because my robot was counting down while drawing, it's already done some of its countdown, so now there's only 8 seconds left until it checks. And now because both robots are looking to block the other, it's just going to be perpetual blocking until there's a draw. So he blocks my chance at winning, and next my robot will block his chance of winning. And this took a long time to set up. We initially just tried to use our normal human to robot code and ran into a lot of collision issues. So we added some extra steps where the robots move to a safety zone before starting their drawing motions. And then they also, when viewing the board and going to home, we have that offset in the Y so that they don't run into each other when trying to look at the board. So both of our robots are looking at the same time. He's the only one that's going because my robot sees that nothing has changed. And now because there's a long wait, I'll cut to when my robot starts moving. Once again, we're both looking at the thing. He moves away because he hasn't seen a change. And my robot has seen a change, so I'll move in. Put my last X. And finally wait for him to put his last circle. And in order to stop our robots from colliding when seeing a finished board, we made it so that our robots would wait after both completing a game and after seeing a game has been completed. This way, I give him time to draw his win condition or his kind of signal for winning or for ending a game, and then he moves his robot out of the way before I write my D for finding a draw. Thank you very much.